In this video, we are going to answer the following questions. Question 1. What is an anemometer? Question 2. What is the importance of making measurements with the anemometer in HVAC systems? Question 3. Which anemometer to use to measure the flow of air coming out of a grill? Question 4. What is the measurement procedure for airflow through a grill? Question 5. Which anemometer to use to measure the airflow inside the ducts? Question 6. What is the measurement procedure for the airflow inside the ducts? But before we start, as always, with a very quick introduction, so that we understand well the main idea of this video. As we know, duct systems allow us to condition a certain area. The idea is to centralize the production of cold air in a single piece of equipment, to then take that airflow to the required areas through the distribution system. From this last definition, we can say that failures in pipeline systems can occur at 2 points. Failures in the generation of cold, and failures in the distribution of cold. Let's start by saying that for the generation of cold, the equipment used can be a package-type air conditioner or an air handling unit. The packaged air produces cold air, with a compression refrigeration cycle, while the air handling unit receives the cold generated by another system, generally a chiller. The best way to know the state of the generation of cold is by measuring the air temperature in the outlets or all the grills. This value must be 10 C or a little less. If the air temperature value is much higher, we can suspect the cold generation system and focus the solution of the failure at this point. On the contrary, if the temperature is 10 degrees C or even lower, but there is disagreement with the air conditioning of the premises, we must focus on problems with the distribution. To solve distribution problems, we need a set of special instruments, which we are going to study in this video, focusing on the anemometer. Question 1. What is an anemometer? It is an instrument, used in HVAC systems, to measure air velocity through grills or inside ducts. The fact of being able to measure the speed with the anemometer also allows us to know the flow of air or volume of gas that passes through the measurement point at a given moment. To measure the flow or volume of air, it is also required to know the value of area A, where the measurement is being made. For example, if the average velocity measurement with the anemometer is 2000 feet per minute, the airflow rate can be calculated using the following formula. The airflow is equal to multiplying the area by the air velocity that was measured by the anemometer. So with the measurements of the duct, for example a rectangular duct 1 foot long by 1.2 foot wide, to find the area you have to multiply both values. So the area is 1 by 1.2, giving you 1.2 square feet. To obtain the flow, we only have to multiply the velocity measured with the anemometer by the calculated area. Finally, the airflow rate is obtained by multiplying 1.2 square feet of area by 2000 feet per minute of velocity. Thus the flow rate equals 2400 cubic feet per minute, also known as CFM. Currently, most anemometers perform this calculation impermanently, so the technician only has to inform the device of the dimensions and shape of the duct, which facilitates the work. Question 2. What is the importance of making measurements with the anemometer in HVAC systems? Through the measurement, the specialist technician in air conditioning duct systems can verify if the airflow that is being supplied to a room is at the correct values. For example, in air conditioning systems, it is often used as a reference that for every ton of refrigeration, the system is required to handle 400 cubic feet of air per minute, or CFM. Question 3. Which anemometer to use to measure the flow of air coming out of a grill? The vane anemometer is the ideal instrument for measuring the airflow through grills. The vane anemometer can be combined with measuring cones to adapt to any type of grid. However, it is not enough to have the best equipment to carry out the measurements. In fact, to do it correctly in the different types of grids is equally important as the quality of the instrument. Now, we are going to describe the procedure to measure the airflow in A. Intake grills, B. Exhaust grills, C. Diffusion or double deflection gratings. Let's start with the measurement of airflow in intake grills. The first thing to take into account is that in a grid it is common for there to be different speed values. This is due to the speed profile of the air. For this reason, when making the measurement, the anemometer must be moved in the form of a serpentine along the entire surface. A good pinwheel anemometer automatically makes a temporary average based on all speed measurements that are made. Take care not to block the grid when making the measurement, since any resistance to flow could falsify the measurements. The best way to measure is to place the anemometer about 5 cm from the grid. The 10 cm diameter pinwheel anemometers are the most suitable for this type of measurement, since the resulting average is made over a larger surface. The best option to measure the intake circuit outlet grills is the combination with the appropriate measurement cone, as it provides highly reliable results. The key factor in a measurement of this type is to ensure that the airflow circulates in the entire section of the grill at a constant speed in the form of a loop. On the other hand, with the cone, the different speeds are averaged, so that the measurement is carried out much faster. B. Measurement with anemometer in extraction grills. For this type of measurement it is essential to have a cone, since the air that is extracted is done randomly from any point in the room, so it is not possible to define a section through which the flow can be determined. This measurement is resolved with the help of the cone, to create defined flow conditions, at a safe distance from the grid through a fixed section area. C. Measurement in deflection grids. It is a measurement that involves some difficulty, since the air normally enters the room in the form of eddies. This irregular flow cannot be measured by the anemometer alone. In order for the instrument to be able to measure correctly, it is necessary for the flow to fall vertically on the vanes of the windlass. The use of the flow stabilizer ensures that the air reaches the blades of the windlass in only one direction. If the eddies rotate in the same direction as the pinwheel blades, this means that the flow reaches a larger area of the blade, so it spins too fast. If the eddies rotate in the opposite direction to the vanes of the pinwheel, the flow passes between the vanes instead of impinging on them, so the speed of rotation is lower. Consequently, an accurate measurement is not obtained. Using the stabilizer, any movement between the airflow mills is cancelled, and a smoother, straight-line airflow is obtained. The anemometer can now measure this airflow reliably and accurately without any difficulties. Question 5. Which anemometer to use to measure the airflow inside the ducts? The velocity probe is ideal for making measurements inside ducts of both volumetric flow and temperature. Some models with a 16 mm windlass, including a probe telescope that can extend in some models to more than a meter. If you have to measure very dirty flows or high speeds, we recommend a measurement with a pitted tube. For this type of measurement, the anemometer must have an integrated differential pressure sensor, as well as a respective measurement menu. Question 6. What is the flow measurement procedure inside ducts? In ducts with a large cross-section, the telescopic extension is used. Thus the telescope of the velocity probe reaches a length of up to 2 meters. On many models, it can be easily attached to metal parts thanks to the magnet located on the back cover. In the duct course taught at Comfort Empresario Latin America, it is taught how to use all the measurements with anemometers and other instruments, to make corrections in ducted air conditioning installations that have problems.